Everyone, and welcome to Mr. Ahmed's Math 20 video screencasts. This screencast today deals with Chapter 3.2, which is the surface area of pyramids, cylinders, spheres, and cones. So moving right on to example 1, it's asking you to find the area of the following figure. Now as you can see, this figure right here is made up of two half circles on each side, and then a rectangle between them. Now here is the width of the rectangle, and here is the height of the rectangle. So figuring out the area of this rectangle right here is a pretty straightforward matter of just taking its width and multiplying it by its height. Okay. Now the tricky part is figuring out the area of this half circle and of this half circle right here. Now these two half circles, when they come together, that actually gives you a full circle. And we are told that from this point right here of the circle, so from one end of the circle down to the other end of the circle, is actually a length of 58.4 centimeters. Now this length is otherwise known for circles as being the diameter. So that would be just from one end of the circle down to the other, that's the diameter. And the diameter is also known as being twice the radius. So that means that if you take the radius and you multiply it by 2, that would give you the diameter. Now the opposite is true, where if you take the diameter and you divide it by 2, that would give you the radius. And if you will remember from the last screencast, the area of a circle is known as, its formula is pi times r squared, where you go pi times r is the radius, and you've got to actually square that radius, okay? So let's figure out the radius of this circle right here. The diameter is 58.4. You would divide that by 2 to figure out the radius of that circle, which is 29.2. The next step is to take that radius and square it to get 852.64. And then now you just, all that's left over in that little formula, which was pi times r squared. Here's our r squared. Well, that means you've got to multiply by pi. And that gives us 2,678.65. Now, that would be the area of these two half circles right here combined. Let's not forget that we do have to add the area of the rectangle as well. So I'm going to push plus, I'm going to open some brackets, I'm going to go width times height. So 112.6 times a height of 58.4. Now I got to close that bracket, and then I push enter, and that gives me 9,254.5. So here it was kind of a two-step process where you had to figure out the area of these two half circles, which together make a full circle, and add that to the area of the rectangle to get 3,306. Okay. Slight mistake here. So I added that. So I did add 2,678, and I did add it to 112.6 times 58.4, and that's odd. My calculator gave me a weird value. Oh no, that's right. Also, there's actually a mistake in your workbook right here. 112.6 centimeters times 58.4 centimeters does not give you 657.84 centimeters squared. Okay, yeah, that's not, so that actually should give you 6,578.4. Likely that they made a mistake with this decimal right here. So let's just test that. 112.6 times 58.4. So yeah, no, they just forgot a little 5. So they actually made a mistake. Your workbook has a mistake in it, and that they forgot that there was a 5. So that would actually be the area of your rectangle, and you add that to the area of your circle, which is 2,678.65, to get a total area of 9,254.5. So please ignore the area that's provided as an answer in your workbook. The right area is actually 9,254.5. At this point, you can pause the video and try out the questions, the Build Your Skills questions on page 150 of your workbook. Okay? If you'll just give me a second, I'm still suffering from that cold, so once again, please ignore the following. Okay. If there was a pause feature in this video maker, I would use it. But otherwise, so moving right on to working with the surface area of a cylinder. Now here's the net of a cylinder. So the net, once again, is you take the shape and you unfold it. So if I was to take the cylinder and unfold it, well, I've got a circle up here, I've got a circle down here, and I've got this curvy surrounding, like it's called the lateral area. And if you were to take a cylinder and unfold it, you'd actually notice that this little lateral area right here, the part that's going around the cylinder, it's actually a rectangle, where the length of this rectangle up here is equal to the circumference of the circle, right? Because this rectangle right here wraps itself around each one of these individual circles, meaning that the width that the rectangle has to be, so the length of this side right here, actually has to be the circumference of the circle. Now a reminder that the circumference of a circle, its formula is 2 times pi times r, where r is the radius. Okay, so that's kind of how you'd go about figuring out the surface area. Excuse me, how you'd go about figuring out the surface area of a cylinder. That would be by excuse me, by adding the area of these two circles together, and then figuring out the circumference of this circle, or whichever one of these circles, and understanding that that would actually correspond to the width of the circle. So once you figured out the width of the circle, the width of the rectangle, sorry, so that's the width of the rectangle is equal to the circumference of the circle. Once you figured out the width of this rectangle, you would take that width and multiply it by its height to figure out the area of that rectangle. Excuse me. Yeah, so sorry about that. Once again, there is no pause feature to this video maker, so I'm quite sorry about that. So moving on to example 2, it's asking you to find the surface area of the cylinder that has a radius of 90 millimeters and a height of 300 millimeters. So the radius here is 19 millimeters, the height is 300 millimeters. So first things first, let's figure out the combined surface area of this top circle and the bottom circle. So the first thing you've got to do is you've got to take this 90 millimeters, which is your radius, square it to get 8,100, and then you multiply it by pi. So this would be the individual area of one circle, which I would then multiply by 2 because I've got 2 of these circles. So that's 50,893. So I'm just going to jot that down, 50,893.8. Now the next step is or the last step actually, is to figure out the area of this rectangle right here, which, remember, its width is actually equal to the circumference of the circle. So a reminder that to figure out the circumference of the circle, you've got to go 2 times pi times r, where r is the radius. So the circumference of the circle is 565.487. That would correspond with the width of this rectangle right here. So that would be the width of the rectangle times the height of the rectangle to get the total area of the rectangle. So this is the total area of the rectangle, and then you would add, don't forget to add your 50,893.8, which was the total surface area of both circles together. So that gives us 220,539 millimeters squared. So there you go, 220,539.8 millimeters squared. At this point, you can pause the video and try the Build Your Skills questions on page 153 of your workbook. Now, the next little topic is dealing with working with the surface area of pyramids. And right here, they're giving you an example. Uh, so find the surface area of the square-based pyramid below. So a square-based pyramid means that the base of the pyramid is 24. It has side lengths 24, and they're all equal, right? So the base of the pyramid is a square. Now, if it's asking you to find the surface area, if you were to take this and unfold it down into its net, you would notice that the net has, well, the one square at the bottom, and then that square is surrounded by four triangles on either side. So I'll say that again. The net of this pyramid is the square base that is surrounded by four pyramids on either side of it. Okay? So what you can do is you can go and figure out the area of the base first, because that looks like it's the most straightforward thing to do right now. So going and figuring that out. So that's its side is 24 and its other side is 24, and we know that the area of a square is just width times length, or just side times side, which is just side squared, right? So 24 times 24. So the area of the base of your square-based pyramid is 576, okay, meters squared. So I just jotted down that number. And now what you've got to do is you've actually got to figure out that what is the area of each one of these triangles, and then add them all together. Now, happily enough, since this is a square-based pyramid, this means that if this is the base of your triangle, because right now we're looking at the triangle part of this right here, right? So all of these triangles have the same base, and therefore they also have the same heights, which are 16 meters. So once again, I am asking you to look at this in terms of net, because this is we're right now we're talking about the height of the triangle, not the height of the pyramid, which is this dotted line right here. We are going to have some questions that deal with the height of the pyramid, so that's why I'm making the difference between the two. This right here, the 16 meters. This is the slant length of the pyramid, or is otherwise known as the height of the triangular faces. Okay, so a reminder that the area of a triangle is known to be, or its formula is base times height divided by 2. But since we've got 4 of these triangles, we probably want to take that area and multiply it by 4, because these triangles are all equal because of the fact that this is a square-based pyramid. Okay, so figuring out the area of one of these triangles, that's base times height, so 24 times 16, divided by 2 to get the area of one triangle, which is 192, but then multiply that by 4, because you've got 4 of these triangles. That gives you 768, which is the combined area of all 4 triangles, which you would then add to 576, which is the area of the square base. That gives you a total area of 1,344. Okay, so that's kind of what they do here. They give you, they do go and figure out these areas, and then they get a value of 1,344 for the surface area of the pyramid. Now at this point you can pause the video and try out the questions, your Build Your Skills questions on page 155. Excuse me. Now example 4 is asking you to find the surface area of the square-based pyramid, and it looks like it's the same type of question as the last one, except here I'll have you notice that for example 4, they don't give you the height of the triangle, they give you the height of the pyramid. So they provide you with the height of the pyramid, which is 9 centimeters. The sides of the pyramid, so this is a square-based pyramid, 24 and 24, except this 9 centimeters is not the height of these triangular sides, right? So this 9 centimeters is the height of the pyramid, is not the slant length. This is what we call the slant length, okay? Which is the height of these individual triangles right here. So what you're going to have to do is that you're going to have to actually use the Pythagorean theorem using the height of the pyramid and half the length of the square base. So if this total side right here is 24 centimeters, and then therefore you can assume that from the middle of the pyramid to one outer edge of the pyramid, that would be half of that. So that would actually be 12 centimeters. So knowing that you've got 9 centimeters here and 12 centimeters here, you can actually use the Pythagorean theorem to figure out the slant length. Because once you've got the slant length, then you can figure out, oh, that slant length corresponds with the height of the triangles. And once you've figured out the area, well, once you have that, you can figure out the area of one triangle and then multiply by 4, because there's 4 of those triangles, and then you can get going from there. Okay, so using the Pythagorean theorem, so you've got 9 squared, so 9 squared plus, I'm going to open a set of brackets, 12 squared, close those brackets, that gives me a total of 225, and we know that that is equal to c squared, or the hypotenuse squared. So to figure out what this means again is that this is c times c equals 225, where c being the length of the hypotenuse. So to figure out what is the actual length of the hypotenuse, you've actually got to take that and square root it. So you square root 225 to get 15. So the slant length is actually 15, which is therefore the height of each one of these individual triangles. So we're going to first of all start off with figuring out the area of the square base. That's 24 times 24. That gives us 576. And then now we're going to figure out the combined area of each one of these, of all 4 of these triangles. Now, the area of one of the triangles would be the base, which is 24, which is the length right here, 24, times its height, right, which we just figured out was 15. That 15, that hypotenuse right here, corresponds with the height of this triangle when you unfold it. So 24, which is the base, times 15. And then divide that by 2. So base times height divided by 2, that's the area of a triangle, so 180. And then you've got 4 of those triangles, so you multiply by 4 to get 720. 720 is the combined total of all areas that are the triangular areas. So you got to add the area of the square base, which we had figured out was 576. So you get a combined area, total surface area of the square base pyramid being 1,296. Okay, so that's kind of what they do there for you. At this point, you can pause the video and try out the Build Your Skills questions on page 158 of your workbook. Now, moving on with working with the surface area of cones, the total surface area of a cone is defined as being its base area, which in this circumstance right here, in this situation, this base area is pi r squared, because it's a circle, so pi times r squared, plus its lateral area, which is defined as being pi times r times s, where s, once again, corresponds with the slant length. So that's what I was talking about in that previous example. S is the slant length of this cone. Okay, so the total area, once again, is pi r squared, so base area times lateral area, which is known as otherwise pi r squared plus pi rs. Okay, so moving on to an example right away. So example 5 is telling you find the surface area of a cone that has a radius of 12 feet and a slant height of 15 feet. So once again, you've got to figure out its base area. So let's start off with its base area, and the base area of a cone, or the base shape of a cone, is a circle, and you're provided with its radius of 12 feet. So pi r squared, that's the area of a circle. So 12 squared is 144, and then times pi. So the base area of your cone is 452.389, and I jotted that down because I'll be adding that to the lateral area of your cone, which is pi times r times s. I actually probably didn't need to jot that down. I can just add. I push the plus button, and then I open the brackets. And the formula for lateral area of a cone was pi times r times s. So pi times r, which is the radius, which is 12, times s, which is the slant height, which is 15. And then you close your brackets, and then you push enter. So that gives us a total area of 1017.9. Okay, so this was really about, so there you go, 1017.9. So this was really about calculating the area of the base, which is pi r squared, calculating the area of the lateral surface, which is pi times r times s, and then adding the two together. Okay. At this point, you can pause the video and try out the Build Your Skills questions on page 161 of your workbook. Now moving on to example 6, it's asking you to find the surface area of the cone. Now, you know that the surface area of a cone is pi r squared times pi r squared plus pi r s. So that's base area times lateral area. Now, for your base area, you're provided with the diameter. You're not provided with the radius, but you know that if you were to take your diameter and divide it by 2, that would give you your radius. So once again, if from this point right here to the center, that's the radius, and they're telling you that from this end to this end right here, so from here all the way over here, that's the diameter, well then that just means take your diameter, 9.6, and then divide it by 2 to get the radius of your circle, which is 4.8. So I'm going to jot that value down. So that's 4.8 is the radius of my circle. Well, I take that and I square it. Okay, I think there may have been an issue here. Let's try that again. So 4.8 squared is 23.04, and then that times pi, because it's pi r squared. So you get 72.38, and I'm going to jot that value down as well. 72.38 being the area of your circular base. Now, the lateral area is pi times r, which we figured out was 4.8, times s. Except you're not being provided with the slant length, you're being provided with the height of your cone. So as you can see, this is starting to look like a right angle triangle right here, where you've got the radius, you've got the height, and using those two, you can find the slant length. So using the Pythagorean theorem, our radius was 4.8, so that's 4.8 squared, so that's 23.04. And then plus, you open a bracket, and then this height is 12.8, so 12.8 squared, close that bracket, okay, and that's 186.88, and then I square root that value to get the length of the side right here of the hypotenuse. So I'm getting a hypotenuse or slant length of 13.67. So jotting that down. So once you have the slant length, at this point you can figure out the lateral area of your cone. A reminder again that the lateral area of your cone is pi times r times s. So pi times the radius, which we had figured out was 4.8, times your slant length, which we just figured out as being 13.67. So here is the lateral area of our cone, which we would then add to the area of our circle, which we had calculated earlier as being 72.38. So that's why I added the two together, and I got 278.52 being the total surface area of this cone. It's 278.5. Okay, so again, the trick here was to figure out the radius using the diameter. Once you've done that, you can figure out the base area, which is the area of this circle. You're provided with the height of the cone, and you know its radius, and therefore you can use the Pythagorean theorem to figure out the slant length. Once you've got the slant length, you would use that to figure out the lateral area, which you would then add to the base area. Okay? So at this point, you can pause the video and you can try out the Build Your Skills questions on page 162 of your workbook. Okay, just give me 1 second here. Okay. Now, right here, we're now talking about surface area of spheres. This is the formula for the surface area of spheres. So SA, so surface area, is equal to 4 times pi r squared. That's the surface area of a sphere. So moving right on to example 7, it's asking you, a ball has a surface area of approximately 9,900 centimeters squared. What is its radius? So you're actually going to have to take this formula and manipulate it. So that means you're going to have to isolate for r. So you're going to have r equals and then a whole bunch of stuff. So you want to take this formula, manipulate it so you're isolating for r, so that way you've got like r equals whatever the formula is. So what you've got to understand is that r squared right here, to be able to access r squared, or to isolate it, you're going to first of all have to get rid of 4 and pi. Now, the way you can look at it is that this r squared is actually multiplied by 4 pi. So this is r squared times 4 pi. Now, what is the opposite of multiplying by 4 pi? Well, the opposite of multiplying is dividing. So what you're going to have to do to get rid of this 4 pi on this side is actually divide both sides by 4 pi. Okay, so that's what they do down here. They're dividing both sides by 4 pi. Okay, that way you've got r squared is equal to 9,900, which is the surface area, divided by 4 pi. Okay, so you divided by 4 pi on both sides to get rid of this 4 pi on this side right here. Okay, now the opposite of squaring, so now that you've got r squared equals surface area divided by 4 pi, the opposite of the opposite of squaring is square rooting. So to get rid of a squared, you've got a square root. So you've got to square root this side, and you've got to square root the other side too. And that's what they do. They square root the other side, and then now you just type in the values. So 9,900 divided by 4 times pi, whatever that answer is, square root it to get 28.07. So let's do that. So 9,900 divided by, and at this point I'm actually going to open a bracket to accommodate my 4 times pi. And then I close my bracket. That way my calculator understands that I'm actually taking 9,900 and dividing it by the product of 4 times pi. So that gives me 12.56637. And then you should square root that. Okay, I may have made a mistake somewhere, so let's try that again. 9,900 divided by, and I open a bracket, 4 times pi. Close my bracket. Oh, enter. There we go. So I'd forgotten to push enter. So that gives us 787.81, and then you square root that to get 28.07 as being your right answer. Now it's really important that you do tell your calculator that this is 9,900 divided by the product of 4 pi. So make sure that in your calculator you're not doing the following. So take a look at this. Don't do 9,900 divided by 4 times pi. And then you get a really weird value that when you square root it, gives you 88.18, which is not the right answer. So your calculator does need the brackets. You do need to tell your calculator, oh, by the way, it's actually 9,900 divided by the, and then you open a bracket to tell it that it's actually the product of 4 times pi, close the bracket, okay? So that way your calculator is understanding it's 9,900 divided by 4 times pi. So whatever the product is of 4 times pi, you're going 9,900 divided by that, okay? And then you get that answer, then you square root it, because you just got to square root what's under there. under the square root, and that gives you 28.07. Okay? So at this point, you can pause this video and try out your Build Your Skills questions on page 164 of your workbook. Just give me 1 second, please. Okay, and then finally, example 8 is the last example of this little subtopic. It's asking you to find the surface area of the composite figure. Now you can see that this composite figure is made up of a cylinder as well as a cone. So you're actually going to have to figure out the area of the cylinder, and you're going to have to figure out the area of a cone. You're going to have to add the two together, except you've got to be careful of this little part right here. The base of your cone is actually not included in the area of the cone. As well, that base is also hiding a portion of this top circle. Okay, so you're going to have to take those two facts into consideration. So it's not just you're taking the area of the cylinder plus area of the cone. You've also got to figure out what is happening over here. Okay, so for the area of a cone, as you can tell, you probably won't be like, it'll be the lateral area of the cone and that's it. You don't see that, like this part right here, you don't see. As well, for the top circle of the cylinder, it's not a full circle because of the fact that this part right here is hidden. Okay, so to do this, what I'm going to do is I'm just going to figure out the surface area of this top circle first. So the circle has a diameter of 11.2, which means that its radius is 11.2 divided by 2. So here's the radius of the circle, 5.6. I'm going to jot that down. So 5.6 is the radius of my circle. And then you square that, because it's the area of that circle is pi r squared, so radius squared, and then times pi. Okay, so this is the area of my top circle, which when added to the area, or multiplied by 2, gives me also the area of the bottom circle as well. So I'm going to multiply this by 2. So I've gotten a total surface area for those two circles of 197.04. I'm going to jot that down too. Excuse me. Excuse me. Probably not the best time to be making a screencast. Okay, so you've got the top area and you've got the bottom area, and those two came up to 197.04. I know that part of this circle right here, or part of this top circle of the cylinder, is missing this part right here. I'm going to deal with that later. Okay, so I'm just going to pretend like I've got like one area of this one entire cylinder, and then I'll subtract this later. Okay, now the next step after this would be to figure out the lateral area of your cylinder. Now, a reminder that the lateral area of cylinder, this actually turns out to be a rectangle where its width is actually equal to the circumference of your circle. So the circumference of a circle is, its formula is 2 times pi times r. So 2 times pi times the radius, which we had figured out was 5.6. This is the circumference of your circle, and this is also the width of this rectangle right here. This is the width of the rectangle. You take that, you multiply it by the height of the rectangle, so 9.3, to figure out the area of the lateral area of this cylinder. So times 9.3. So here is the area, the lateral area of the cylinder. Okay, so this is the lateral area of the cylinder. And then now I'm going to add it to the area of both these circles, which we had figured out before was 197.04. So this is what the area of the cylinder would be if it was just a standalone cylinder, but it's not. There's a cone on top and it's hiding a portion of that area. So if you'll just give me 1 second here, just gotta blow my nose again. Okay, So this would be the area of your cylinder if it was a standalone cylinder, but it's not. It's missing this little part right here. So I'm actually going to figure out what this area is right here, and then just subtract it from this. Okay. So this radius, it's showing us that the radius of this circle is 3.4 centimeters. That means that the area, sorry, the radius of that circle right here is 1.7. Okay, so let's figure out the area of this little circle right here. So 1.7 radius squared times pi. It gives us 9.0792. So that is the area of this little circle right here. That means that that's the area that's being hidden of this cylinder. So you know how just a minute ago we had figured out that the total surface area of my entire cylinder was 524.26829, and I'm actually going to subtract what we had just figured out was the area of the circle down here. Okay, so that gives us 515.189. So I'm going to jot that down as well, 515.189. Okay, so now this is the total surface area so far, excluding the lateral area of the cone. So now the last step is to figure out the lateral area of the cone, which a reminder again is pi times the radius, which in this instance it was 1.7, times the slant length. Okay, and then you add that to this value right here, which is what we were at so far. So I'm going to add, and then so pi times the radius of the cone, or of the circle, the circular base of the cone, which is 1.7, times the slant length, which is 8.6. And I'll close my bracket and I press enter. So the total surface area of this composite figure should be 561.1. Okay, so again, you figure out the total surface area of the cylinder. You make sure you subtract this area right here that you can't see because it's being hidden by the cone. And then I just went and figured out the lateral area of the cone. I didn't even bother figuring out the base area of the cone because once again it's the area that's hidden. So I just figured out the lateral area of the cone and then added it to that the area of the entire cylinder subtracted from this. Okay, and then that gave me 561.1, which is what you're getting there in your workbook. Okay. So at this point you can pause the video and you can try out the Build Your Skills questions on page 166 of your workbook. You'll also notice that the Practice Your New Skills questions are also right on there as well. So that concludes this chapter. So stay tuned for the next chapter.